Alright everyone, today we're going to talk about 10.4 and 10.5, common logs as well as natural logs. Now, common logs, what that's referring to is probably the most common log, and that is log base 10. We're also going to use a little calculator stuff here today, but this idea of log base 10 is something that I want us to kind of become familiar with. All of our calculators have a log button on them, and there's just labeled log. It's not log anything, like log base 2, 3, 4. That's because your calculator is assuming anytime you hit that log button, it's a base of 10. So anytime you see this log x, that really means log base 10. Okay? So for instance, if I say log 100 is equal to 2, that's because if I were to actually write it like this, log base 10 of 100 of 2, if I write that exponentially, that means 10 squared equals 100. So that is true, that log of 100 does equal 2 because 10 squared is 100. Now you don't have to put the 10 ever. If you write log and you forget the 10 or you forget this base, it's assumed it's 10, so make sure you're careful with that. So this is actually fairly easy. Today's not a complicated day. We're just going to talk about how to use your calculator. So for instance, if I just ask you to use or to simplify these things, let's say we're going to go to the nearest thousandths place. So if I'm going to type in log 31.2, I'll just hit log, and then I'm going to hit 31.2 and 1.49, 10, 100, I said thousand, so 1.494. Now, it's kind of important that this makes some sense to you. Let's go back to what we were just talking about. What does this mean? Well, it means log base 10, the 31.2 equals what? Well, if I write that exponentially, that's 10 to the x equals 31.2. Well, you know obviously 10 to the first is 10. You know 10 to the second is 100. So somewhere in between here is 31.2. So therefore, my answer is going to be somewhere between 1 and 2. Well, the answer is 1.494. Okay, so the answer does make sense. So let's do some other ones here. Log of 4.1. So again, I'm just going to do log 4.1. Okay. 0.6128. Okay, not super tough there. Last one. As always, hit pause, see if you can do this one, but I'm going to give it a shot. So this is log of log 192.3. So let's see what we come up with. So I'm going to do the inner one first. So log of 192.3. Okay, so I get 2.2, etc. Now I'm going to take the log of that. So I'm going to do log of the previous answer. So my answer is 0.3587. Now, something to be careful about is when I say round to nearest thousandth, that means final answer. So on this one, if I'm going to do log 192.3, you don't round this answer to the nearest thousandth and then do log again. You have to use this whole thing. Now, some of your calculators will allow you to do this. They'll allow you to just do log 192.3, and you see I get the exact same answer. So depending upon your calculator. All right, now the next thing we want to do is work on going backwards. Well, that's called the anti-log. The anti-log, as I have written here, just simply means you're going backwards. So for instance, if log of 100 equals 2, then the anti-log of 2 is 100. Now, on your calculator, you have a button for this as well. You should have this button. You have the button 10 to the x. And hopefully this makes sense, but if here's my log button, the 10 to the x is right above it. See it right there. Okay, and how do I get there? Well, usually, depending on your calculator, you hit Shift and then hit that button. Now I have the second button, so I'll do that. So if I'm asking you to find the anti-log of 3.4, what I'm really asking you to do is do 10 to the 3.4 is what I'm looking for you to do for me. All right, so what is that? Well, I will have to do 3.4. Oh, pardon me. I'm going to do that to 3.4. So if we go nearest tenths place, I'd get 2511.9. Okay, the anti-log of 3.4. Let's do this one. How about the anti-log of negative 1.652? So that would be 10 to the negative 1.652. So hit my button, and then negative 1.652. So hopefully it makes sense. That's the negative, so it'll be dropped down, so it'll become a fraction. So if I go nearest tenths place, this would just be 0.0. So let's actually go a couple more spots. Let's go to the hundredths place in this case, 0.02. And last but not least, let's do this one. So the anti-log of that, so I'm going to just do 10 to the 0.2456, and I get 1.8. Okay, so fairly easy right there, just using our calculator to go forward and backwards. Like I said, nothing too difficult. Next, let's move on. Let's move on to something that will be completely different, and that is this thing called Euler's number, okay, or natural logs. Natural logs are just a special type of log, kind of like how we have log base 1, log base 2, log base 10, log base 30. This is a special type of one. And it involves this thing called Euler's number. Okay, Leonhard Euler was a Swiss mathematician. There's a lot of uses for this number in upper level mathematics. We're not too concerned about that right now. Let me give you a value. Euler's number is represented by the letter e, or e to the x, but more specifically e to the first power. And that's equal to about 2.718. Okay, and we have special notation for Euler's number, and that is, it follows along with what I have here in this box. That if I have log base e of x, I can write that using this notation, ln of x. I know it seems a little backwards, ln, but it's natural log. Okay, but ln of x means natural log. So anytime you see ln of x, it really means log base e of x. Okay, now the nice thing is this is just a log. It's just a special type, kind of like how we had log base 10 a few minutes ago. This is just log base e. So that means all the different rules, properties, the power property, product property, the property of equality, all those things that we talked about apply to natural logs also. Now, what also is fairly nice here is that we are going to go through and use a nice little button on our calculator to help figure these out also. So when I talk about the natural log, and that's how you say it, you say the natural log of 2, okay, that would just simply, you notice here, here's my button, ln, it's right there by the log button. Okay, so if I'm going to find the natural log of 2, I'm just going to literally type in ln of 2, and I get, if we go, let's go thousandths place again, I get 0.693. 0.693. So not super tough, but again, what does that mean? Well, what that really means, okay, is this log base e of 2, okay, equals x. Okay, if I really wanted to get crazy and write it exponentially, it'd be e to what power equals 2. Well, let's just look up here. Notice here it said e to the first equals 2.718. So I want to know, what does e to what power will equal 2? So you know it's going to be less than 2. It's actually quite a bit less. It's 0.693. Okay? So not super tough. So let's go through and practice again. Let's take our calculator, natural log, 0.735. is, if we go thousandths place, negative 0.308. Let's do the next one. Natural log of 128.24. Alright, so I would type in, let's see, what do we get? 4.854. Now, what is the natural log of e? What do you think there? Without even doing it on a calculator, what do you think? And I'll give you a little hint. What if I rewrote this back up here using this? So instead of natural log of e, I'm going to write log base e of e. What do you think that is? We had our little property that told us that. Hopefully yours telling me that it equals 1. Well, let's type that in. So natural log of e, I need to know what power, so it's to the first power, equals 1, just like that. Okay? So natural log of e simply means this, log base e of e, which is, remember that property says if these are the same, it's equal to the exponent, so it's to the first, or it equals 1. Simple enough. Now, just like with logs, we had anti-logs. Well, we have anti-natural logs also. Well, when I say an anti-natural log of x, that simply means e to the x. Kind of like how we had anti-log of x equaled 10 to the x. Now, as I look at these things here, you look at your calculator, notice again, just like how we had with the log, we had the 10 to the x here. Natural log, we have e to the x here. So let's come down here. Now I got a little typo here. Sorry about this. This should actually say anti-natural log of 3. So if I'm going to figure that out, I'm going to just simply do second and hit e to the x to the 3. And that equals, if we go, let's go tens place again. So 20.1. Easy enough. And last one, anti-log of 1.4. So I'm going to just simply do e to the 1.4. And that's equal to 4.1. Alright, that's it. That's all we're going to talk about right now. We can get into greater detail in class, but hopefully that all makes sense. So there's 2 sections. Hopefully you have these down. And as always, if you have questions, make sure you bring them to class. All right. Thank you.